Babak Hodjat is the mind behind Siri's foundational technology, and he's going to join us today on the AI Inside podcast to discuss the evolution from early voice agents to today's multi-agent AI, the challenges of making these systems interoperable, and why transparency is critical as we deploy black box models at scale. That's all coming up next. This is AI Inside, episode 80, recorded June 27th for Saturday, July 12th. From Siri to multi-agent AI with Babak Hodjat. This episode of AI Inside is made possible by our amazing patrons at patreon.com/AI Inside Show. If you like what you hear, head on over and support us directly, and thank you for making independent podcasting possible. Hello, everybody. Welcome to another episode of AI Inside, the weekend edition, or whatever you want to call it. I'm one of your hosts, Jason Howell. Other host, Jeff Jarvis, of course, joining for the interview here in a few minutes. But I'm very excited to welcome to the podcast a longtime pioneer in AI, Babak Hodjat. He's an AI scientist and entrepreneur. He's best known as the primary inventor behind the technology that powers Apple's Siri. He actually co-founded Dejima Inc. back in the 90s, and they developed agent-oriented natural language technology that ultimately became the foundation for Siri's conversational capabilities. He also helped build the world's largest distributed AI system at Sentient Technologies, and he now serves as Chief Technology Officer for AI at Cognizant. It's a fascinating conversation all about agentry coming up next with Babak Hodjat. Babak, it's a pleasure to get you on AI Inside. Thank you for carving out some time to talk to us today. Appreciate it.
By all means, a pleasure.
You have a very unique history. Everything that we talk about, all the time on the show about kind of voice agents, using our voice to interact with the systems that we're used to interacting with. Of course, there's kind of like the previous generation of that, Google Assistant. Siri, for certain, can be kind of considered that, even though Apple's working hard to kind of revitalize it and make it more modern and everything. But then also kind of like the very modern kind of AI assistants and agents and everything that we're using our voices to interact with. And your history, in your experience, takes you back to Siri, and actually prior to that, because you were working, is it Dejima? It was the company that, and basically creating the technology that ultimately led to the original incarnation of Siri. And I guess that's a great place to start. Can you kind of take us back to those days when you were working and co-founded Dejima, and share a little bit of what that original vision was that led to Siri's kind of natural language technology that everybody has seen and interacted with?
Definitely. Yeah, I got into AI very early on, late 80s. And the trajectory was, starting to create this one monolithic system that is really intelligent and more intelligent than humans. And of course, when you start doing that, you can't actually simulate the world in which a human operates. So you have to simplify that world. The moment you do that, you have these simpler and simpler idiot savants that do really, really well, and they exhibit, facets of intelligence in that simplified world. And then it's very tempting to start wanting to have more than one of them, and having them operate in some sort of, ecosystem or society. And then you observe these emergent behavior, which is fascinating. So that was sort of the arc of where I was. And I had observed how powerful these systems can be when you build them as modular, like agents, what we did call agents back then. And I was looking for an application, and a friend of mine misunderstood what I meant by an agent. He thought an agent was this intermediary between technology and a human, so literally an interface that understands our language and our intentions and can map it to the world of very sophisticated technology like the VCR, because back then the VCR, like recording.
It was a big deal.
Exactly. It was a big deal. It was hard to do. Initially I made fun of him, and I'm like, natural language is not easy. And he made fun of me back. He's like, if you think AI is so powerful, you might as well use it on a problem that's not easy to solve. And I took that challenge. And in fact, the original design for what ended up being the natural language behind Siri was very much multi-agentic. Again, we're talking, agents of the past, which are much simpler and required a lot of engineering. And so we actually tackled the problem of understanding a natural language system and command and control using a multi-agentic system. And to my delightful surprise, it actually worked very, very well. It was extensible. It was language independent, so you could very easily port it from one language to another because it kind of really took the domain of discourse. It was the semantics that really mattered, not the grammar. The grammar was secondary to it. You could actually be non-grammatical, and it would understand what you're talking about. So we started building on that, and it was very flexible. And of course, the first use case was to control your home entertainment system. And very quickly, we realized that is not going to make us money. And we kind of pivoted to more, B2B kind of applications. And that technology ended up being the basis for Siri.
So I know your concentration is AI, and that's what we want to talk about on the show about AI. But I just for a minute, I'm curious about that interface layer. And voice was presumed to be it at various phases, on and off. And it was hot, then it's been cold, and now it's kind of coming back. What do you think the best human interfaces are to these agentic structures that can understand you? I mean, I'm fascinated by AI as the literate machine. That it speaks our language and we can speak its language in essence, right? But what does that imply then for the best media and interface to them?
Language is very powerful. I mean, when you think about it, it's what sets us apart from other, animals and living things. Because it's so expressive, humanity kind of stumbled upon this way of expressing and communicating. It's not that other animals don't communicate. It's just that they can't communicate in a future-proof way. And we can, because we can actually put concepts together and create new concepts that never existed before. And that's been the engine of communication, progress, a lot of different things. So it is indeed a superior mode of interaction and communication, and we seem to have kind of cracked it with large language models. So it is important to always consider that as part of that interface, but it's not the only part of the interface. I mean, oftentimes, a visual, clicking on a button makes more sense. I mean, going back to our naive initial days at Dejima, I had the system completely running with language. So if you wanted to turn the volume up, you had to say volume up, volume up, volume up. That's just stupid, right? But, it's language. Up. Exactly. But so, we've come a long way in understanding how to interact with various different systems. And it's multiple modalities that work at the same time. Back then, speech recognition was not as far along as it is today. So, often, our first successful use cases didn't even have speech as the interface. You would actually use SMS, text, or email even for some of the business applications. So it's a combination of them. It's never taken off the way we expected it. We thought if we had this view. Right, we thought that if we had a system that understood language, we're done. This is it. But it's not. Like having a cylinder in the corner of the room that you can talk to is not conducive to you actually talking to it. And you don't anthropomorphize it. It doesn't have eyes. It doesn't look back at you. You don't. It's just a cylinder. So why talk to it? So I think even solving the problem of understanding natural language does not mean necessarily that that's the be-all, end-all of interfaces.
If you had, so much has changed over the years. Even when we were talking about, you working in the world of AI and the kind of universe of AI back then, AI and what it meant then versus what it is now seem to be two completely different planets, right? Just because it's so much more capable now than it was back then. And so to hear you kind of talk about this is kind of, it's fascinating to me because I'm like, oh, wow. So, it seems so now to think about agents and to think about voice agents, but this really does date back quite a ways. And I'm wondering, like, with kind of that time scale and that history as your perspective, what could you have done differently then, or what would you have done differently then if you had the capabilities that we have right now? Obviously, it has to start somewhere and it builds out, but I'm just kind of curious, like, how would things have been different back then?
Yeah, I mean, there are similarities and some fundamental differences, obviously. Like with large language models, you have a system that understands language out of the box.
Right.
But you're still putting it in a box. That's the ironic, interesting thing about how we've come full circle back to agency. You have this system that speaks all languages and can understand and map it to various different actions. But for us to actually practically use it, we still do need to put it in a box, give it a job description, give it a finite set of tools, and have it operate. And then say, well, okay, now that I have this knowledge worker in a box and I have this other knowledge worker in the box, it does make sense for them to talk to each other. And you're back to multi-agentic systems. If I had large language models back then, I would still put them in a box because it would make them extensible. Because, if you're talking to Siri and you have, 20 different apps that you can operate, and app number 21 comes along, you don't want to go re-engineer everything all from scratch again. You want that app number 21 to be represented by a large language model and plugged in, and automatically that domain of discourse to expand. While there is this fundamental difference, there are some really interesting learnings from back then that we can pull into the world of modern LLM-based multi-agent systems, one of them being this coordination mechanism. How do you get these agents to talk to each other and coordinate and spontaneously form teams and get stuff done, breaking the silos of that organizational setup that you have for them is not trivial, and it's something that we had to deal with all the way back then as well. So some of that does carry over, even though the technology is so much more powerful today as it was back then.
All right, just going to butt in real quick here and give a big thank you to those of you who support us on the Patreon. That's patreon.com/AI Inside Show. The name of the week has to be Chris Spackman. Chris, thank you so much for your support. And to all of you who support us, maybe one day I'll read your name in the middle of a podcast very suddenly. All right, we're going to take a quick break and then get back to our interview with Babak.
So we talk a lot about, and I really want to get into agents because that's what you're doing, and what you're doing now at Cognizant. But one preamble here: we talk a lot about large language models replacing coding, and that's a whole Megillah. Mm-hmm. But as I hear you talk, I wonder whether agentic systems replace APIs. That the structure we had before was you had a database and an application and an API, and you knew how to write to it and you knew how to deal with it. And now what I think I hear you saying is that it's a lot more fluid, and that you don't necessarily, even though it's in a box and that's the HR agent and that's the onboarding agent and that's the healthcare insurance agent, whatever, right? They have boxes. But what I think I hear you saying is that their interaction, Sans API, can now be more fluid. Am I crazy?
No, you're not. And it actually points out a very interesting property of these systems, which is they provide this buffer, resilient, robust buffer between the intention of the system and the rigid calls to the API or apps and so forth, which means that once you actually identify your system, you can afford to then swap in and out these back-end rigid applications without having to re-engineer everything and or go through this very elaborate integration process that we always go through. I mean, it's amazing. At Cognizant, we have clients that still run Siebel systems, still run systems on mainframes. Folks who put these together are long gone, and not just gone, they might be even dead. Who knows, right? These are like 30, 40-year-old systems. Okay, one way around this, rather than doing a 5-year modernization project by which time whatever you've modernized to isn't modern anymore, is to actually agentify that mid layer, so that the next API, next system that you bring in 6 months that's superior and works better, the mapping is automatically there and done, because the large language model can code and can understand language. So you have this system that understands language and maps it to the back end. And so it's actually a very keen observation, Jeff. The fact that this allows us this separation means that we this always like chasing our tail, trying to update and upgrade is less of a thing right now. It doesn't mean that API goes away. Like, applications will always be there. You always have to have a deterministic layer of, here's where I store this thing and here's how I operate that other thing. That is always going to be there. It's just that the integration is easier and you have this buffer, which is the agentic layer.
So describe what you do at Cognizant and how you agentify things.
Yes. So we either identify what the existing process is. There are instrumentation that can be used to do that. It's not always the process the client thinks they're following, by the way. And what the organization structure is and where is the biggest bang for the buck. That's where we start. And we start creating agents. It's not always the one-to-one relationship between, some human or app is operating this thing, therefore I'm just going to replace it with an agent. Agents are powerful, but they're not that powerful. So you might actually consider creating a multi-agentic system even for one part of the process. And it's not always a replacement. There's almost always an augmentation. And so you build this. So what we do is we build that nucleus, or help our clients build that nucleus. And we also help our clients with the process of how you extend and expand it, so that the client can empower their teams to come up with their own agents or bring in provision third-party agents. I don't know, Agent Force, Agent Space. There's a lot of agents out there, and plug them in to this larger agentic fabric. So nucleus, extensibility, how do you make it responsible? What is the user experience going to look like? How do you make this entry point agnostic? There's a lot to this that our company helps our clients. And I always say, we're kind of half a step ahead of our clients. We're doing this for ourselves and making our own processes agentic as well.
When you're talking about these multi-agentic architectures, I'm just realizing, not being as fluent, let's say, or as experienced in this world specifically as closely as you are, it sounds like, is there a need for like a common language or some sort of like common unifying thread to connect all these things? Or is that a problem that's already solved? You're talking about all these third-party kind of agentic systems and everything. Are they all speaking the same language? How complicated is it to get them talking together?
Well, at a certain level, they are. So, I mean, not to make it sound too simple, but they all have large language models. If it's a modern agent, it has a large language model. And
those are inherently at this point, very good at language, so it can kind of figure that stuff out.
Regardless of what LLM you're using, it understands language. So you can just connect, but you don't want to do that. For example, for coordination and encapsulation reason, what do I mean by encapsulation? If I have an agent and it has some job description, I don't want it to tell everyone what it's doing or other people to kind of know the innards of what it's responsible for, which immediately means there's some interface, and there's some exchange. So for example, two agents getting to each other will have to coordinate by saying, look, I have this intent that came in, and I think that you can probably resolve part of it or service part of it. Take a look and let me know what you need. So give me the requirements for it. That's sort of a handshake. And so that at that level, there's some structure to how we devise this coordination and interagent communication. And there are some protocols, like Google came out with A2A and they just open sourced it. We have an open source platform that we've put out there primarily because of this. We want, to be able to connect these agents and help with the coordination. So regardless of what large language model you use, what platform you're running, you can actually connect and make these things interoperable. There's MCP. I'm sure you've heard of this protocol. Basically allows you to create this agent readable interface into whatever you have. So standards are starting to emerge. I'm actually going to be at the UN in a couple of weeks, where we're actually directly with the ITU, which is the standards body. We're directly tackling the standards for interoperability, extensibility, and safety and trust for these multi-agentic systems. They're starting to emerge.
Yeah. This is a really stupid question, but we say we do this podcast to learn, so that's why we're here.
That's right. That's our excuse.
you talked about that. You're fascinating me here because you talked about that buffer where they interact and they move. Behind the scenes, where we don't see it, are agents making up their own languages?
That's another awesome question, Jeff. It's been observed, especially when you set up these large language models to do chain of thought reasoning, which means think about what you want to do first, write it down, make that part of your context and go to the next step. It used to be that these chain of thoughts were all in English. Mm-hmm. And partly because the large language models that they started on, like GPT-4o and so forth, were natively English. When DeepSeek came out, one thing that was really fascinating was when you gave it chain of thought reasoning fine-tune, part of its chain of thought was a mix of English and Chinese. And people start scratching their heads and thinking, wait, this is interesting. These are they have been trained to be multilingual out of the box. And it seems like they're very comfortable using multiple languages at the same time. So there's this whole line of inquiry as to whether or not, and still a question, whether or not the internal thinking, quote unquote, of these large language models is some other language, some made up way of abstracting the world and representing it and thinking about it.
Because it's just tokens in the end.
It's just tokens, exactly. And these tokens basically are a taxonomy abstraction of the world that seems to reflect how we, abstract the world. But it's not necessarily, the thinking isn't necessarily in one language, which is fascinating. It's amazing that's happening.
That's super fascinating because when I think about language and the kind of variability between the wide scope of let's say the dictionary and how I know to speak in English, different languages have different concepts and ways to describe the world that we have no analog for in English, and dotted throughout them all. So when you've got an LLM that understands, again, in air quotes, we could probably put air quotes around half of what we say, but that understands all of those nuances, that actually makes the system possibly more, smarter than if, about kind of contextualizing the world than it would be if it was just locked into a single language.
Look, here's something controversial. It seems pretty clear that we abstract emotions differently depending on our language and our culture. There's no universal emotional abstraction that's happening here. And these are higher order, very socially and contextual concepts, emotions. And so to your point, Jason, if you have a system that's multilingual at that level and can, again, quote unquote, understand emotions universally across languages and cultures, how much richer is that than someone that's experienced one or two cultures and languages in their lifetime?
So I'm the idiot American who speaks 1.1 languages, really bad German. May I ask, do you speak multiple languages?
I do, yeah.
Do you interact with these models in those various languages? And
I do. That's what all of us in AI have, this little barrage of litmus tests that's very anecdotal that we run against new large language models as they come out. And mine do. Yeah, I do. I speak Persian. One of my litmus tests has been, uh, uh, write me poetry in the style of Hafiz. And Hafiz is like the biggest poet in Iran, and very layered meanings and all that. And it's not passed that test yet, and I'm hoping it never will. But that is like you do kind of test the boundaries by checking to see whether it will be able to do that sort of thing.
You're hoping it never will, but do you think it will eventually?
If you like the problem with Hafiz is that he only has several thousand poems. And so you don't have a lot of instances of that kind of nuanced meaning to train on. And it's just this one guy that came up with this poetry that some people just memorize because it's so beautiful. Maybe for others, you could expect it to do that sort of thing. So I don't know. Especially, look, we talk about large language models being so powerful. They have limitations. I mean, we have to acknowledge that they have to go over and over a very, very large corpus and imitate it to be able to abstract this way. And so they have limitations and requirements that aren't easily fulfilled for certain things that we expect them to do.
All right, one more interruption. Sorry to interrupt, but if you are enjoying this show, maybe not the interruption itself, but the show as a whole, please leave us a review on Apple Podcasts. It's a huge help. It really does go a long way to get the word out. Okay, going to take a super quick break and then back to the interview.
I constantly remind people that large language models do not have a sense of meaning. Yet when agents interact with agents, there is an exchange of meaning of some sort, yes? So how do you define meaning in that world?
Yeah, I'm not sure if I agree with the premise.
Okay.
Meaning being some form of abstraction, I think they do that very well. That is the big breakthrough.
Okay.
And conveying meaning, especially if you have the same large language model behind the two agents that are talking to each other, I think you would expect that meaning is conveyed rather faithfully. Okay. Maybe still not 100%, but rather faithfully. And it's conveyed through language. So yeah, I think there's that aspect that I think is covered. I think so. But reasonable people can disagree.
Maybe talk a little bit about safeguards, because I know, in doing some reading around Cognizant, some of the work that you do around kill switches and safeguarding these multi-agent systems. Maybe talk a little bit about kind of what goes into that. What are some of the real concrete considerations that you face in that regard?
When you think about an agent is a combination of a large language model and code. Mm-hmm. So that gives us a lot of flexibility because
I love that you put it that way. By the way, let me just real quick say that set off some fireworks for me for some reason. That's a simple way to describe it, but you're spot on, and I had never really considered that before.
That's right, and so the large language model part, we need it because it understands language. Wow, that's awesome, and it can map it to code, so that's great, and it can do some reasoning. Wonderful. Those are things that if you have it packaged in a module and you can use it, that's great. And that's why, we have this whole AI revolution. The code part, though, is what empowers the language model. The language model has an intent, like call this API. The code looks at that intent in the output of the language model and actually goes and does it. That code is written by humans. The large language model, we don't have a lot of control over it. I mean, it's black box, and sometimes it hallucinates and so forth. So
maybe some influence, but maybe not control.
Some influence, yeah. We can tell it stuff, and more often than not, it will follow our instructions. Even many times, we kind of find that our instructions were vague, and that's why the system didn't quite do what we asked it. In any case, when we talk about safety, it's important to note that we do have this choice of which part of the behavior of this agent we're going to defer to the large language model and which part are we going to write in code. And we can easily make mistakes here and over rely on the large language model and, be subject to hallucinations or inconsistencies. Or make the counter mistake, which is like, everything is rule based and I'm going to write a ton of code here and the large language model is not going to do anything. Well, that defeats the whole purpose, right? You don't, it's not an agent anymore. So you have to explicitly decide which part of the job description of this agent is going to be autonomous and done by the large language model, which part is not, and how am I going to...
Which is trusted to do that.
Which is trusted to do that.
Big time.
And so, for example, things such as, for this particular part of what this agent is supposed to do, I'm not going to give it to the large language model, and I'm going to have the code actually do that. That's a threshold. And so you have to define that. You have to define it for the large language model, and you have to actually encode it in the code. It might be very blunt, and you can say, for these things, go to a human. That's great. But before you even go to a human, you might want to go to some rules that you've encoded in the code. There are some tools. And one of the things that came out of our lab is this assessment of confidence. So the large language model now, we have this, it's an approach called semantic density. You run the query 5 times or 10 times against the large language model, the same query, and then you can calculate what is the large language model's own confidence, absolute confidence in its output. And so then you can set a threshold. You can say, look, if what is being asked of you, you don't have a response that is better than 85% confidence, we go to human or we go to code. So there's a bunch of different ways that we can mitigate this risk, reduce the chances that the system does something that we didn't expect. And it also translates over to how you do this in a multi-agent setting. So because you have that encapsulation, that's a whole can of worms.
So Jason and I have been talking the last few weeks about advertising and in an agentic world. After Meta came out and said that they're going to make everything AI for advertising. And a lot of us are fascinated with the idea that marketers will soon be marketing to agents and not necessarily just to human eyes. And propagandists can do the same thing, and others can do the same thing. So how do agents become an audience, a market, a population? Is there a lot of science going into how to influence agents externally? What does that world look like?
Yeah, I mean, let's say you're a B2C company, let's say you're Airbnb or Booking.com or something, and you create a multi-agentic system to serve your users, like to make it easier for them to book, some vacation. There's nothing that says that a human wouldn't be able to have an agentic system serving them, like a consumer, and have that go do the negotiation, like be connected to all three, like Booking.com, Expedia, whatever, and do a negotiation, run one off the other, and try to come up with the best vacation package for me. But the inverse then becomes interesting as well. Like, okay, now that I know that my multi-agentic system is being used by other agents, how do I influence them to go with me versus the other guy? And, unfortunately, these large language models are fine-tuned to be aligned, which means that they are very kind and they're often very gullible.
Right.
And it might be easier to market to them than a human, especially if they think that there's a human user talking to them. So that's a whole, again, talking about can of worms, that's a whole new area. We're not quite there just yet, but it is this whole concept of agents that are not aligned with one another fully. When you're building a multi-agentic system for Airbnb, all the agents are working for the same company. They're fully aligned. But if they're now talking to agents that work for some other company or some consumer, that is, I realize I didn't answer the question, but this is a fascinating, huge topic, and it's going to hit us before we know it. And what I'm afraid of is what has happened on the web. Like, you have the analogy of that, like in the web without using AI, you already have that. If you're out there, you want to buy a car, and you look for you're doing comparison shopping, you get these web pages that actually, lo and behold, were curated by car companies comparing cars, right? So who knows where this is going to go, but it's a fascinating topic.
Yeah.
Well, yeah, and definitely, beyond that, not just what's happening behind the scenes in that kind of interconnectivity and the negotiations between the agents or whatever, but also the clarity, the how that is acknowledged to the person on the other end who assigned the work to the agent. Is there any sort of disclosure about that? And I mean, I feel like we're so far away from that when we're talking about these systems as well. It's very confusing to know what the intention, what the motivation is, and who's directing that motivation.
That's right. But all the same, it's starting to happen. We did a whole research with Oxford Economics earlier this year. And it turns out that users, and especially the younger generation, not too many are comfortable with agents going off and actually, buying something, doing the transaction. But they're increasingly comfortable with the agents coming back with some choices for them.
Yeah.
Mm-hmm.
But there's a decision inherent there. Like, you're not showing 100 different things, you're showing 3. How did you whittle it down to 3? That is already, right, you're trusting it to do that. And so that's one of the biggest risks, is just over trusting these systems right now without the transparency. And at their core, these are black box, opaque systems, large language models.
Yeah.
So you've been doing this stuff professionally since the 90s.
The
And
80s, yeah.
80s, okay. So you've been living in this world of agents and AI. And then the world suddenly discovers large language models as if they were completely wholly new, come ChatGPT. And then more recently, agents seem to the rest of the world new. I always love hearing scholars and experts like you talk about your worldview of that versus your neighbors, and how much of this really is new to the world or just recently discovered.
Well, the underpinnings are a continuum. A lot of what seems very new to the world is something that was expected and we've been seeing. There are cases where it's delighted us all. I mean, those of us in AI, we live for those moments where the AI system does something we didn't expect. Large language models is one of those.
It is.
If anyone, including the folks that wrote that paper, tell you that they were expecting large language models to exhibit this kind of emergent behavior, they're lying. We didn't. No one expected this, and it happened. It turns out this confluence of scale and a lot of data and breakthroughs in neural networks, brought about this huge step up. But it does come at a cost. A lot of the techniques in AI that are still very promising and interesting and have potential in resolving some of the limitations of these systems are being sidelined because we're sort of single tracking basically on a certain kind of, first of all, neural networks trained in a certain way, organized and architected in a very certain way, and used in a very certain way. So so for those of us who have been in AI, we're kind of like, yes, great, but there's so much more that you can do, but all the money and all the attention seems to be going in one direction right now.
And the surprises are fun, but also make it more difficult because it's not as explainable.
That is part and parcel of neural networks and deep learning. Yeah, definitely.
You have a fascinating job, and thank you for sharing this with us.
Yeah. Babak, it's been a pleasure meeting you, and talking a little bit about agents. I mean, like I said, we talk about the topic of agents on the show all the time. It's great to talk with someone who's living and breathing it and has such a rich history in it. Babak, thank you for your time. We appreciate you.
My pleasure. Thank you.
Super cool stuff. I knew when Babak's name flashed by my inbox, I was like, I got to get this guy because he's got some like incredible context about working in the AI industry from such an early time, so much influence over that time and what it's evolved to. Fascinating stuff. I'm really happy we had the chance to get him on the show, and big thanks to Babak once more for his time. Don't forget jeffjarvis.com for all things Jeff. If you want to find all things this show, go to aiinside.show. You can find our show notes, links, audio, video, subscribe links, all that stuff. And then finally, if you really, really love what we're doing here, support us on Patreon. That's patreon.com/AIinsideShow. You get ad-free episodes, Discord community. You get an AI Inside t-shirt by becoming an executive producer like Dr. Do, Jeffrey Maricini, WPBM 103.7 in Asheville, North Carolina, Dante St. James, Bono De Rick, Jason Knifer, Jason Brady, and Anthony Downs. Thank you all so very much for your support of this show. It really does mean everything. And thanks to you for watching and listening. We'll see you next Wednesday on another news episode of the AI Inside podcast. Take care, everybody.